Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here, and it also helps us reach others in need of assistance with these topics. So what we're going to be discussing in this video is that we are going to be going over statics, equilibrium of rigid bodies, and we're going to be finding reactions for this problem, and this will be the ninth part in this particular series. So what we have going on here is we have this picture with a lot of forces and a lot of dimensions, and the description says a load of lumber that weighs 25 kilonewtons is being raised as shown by this mobile crane. Knowing that the tension is 25 kilonewtons in all portions of cable A, E to F, so this blue line right here, and that the weight of the boom A, B, C, so this top portion right here, is 3 kilonewtons as shown. It says determine the tension in rod CD, which is right here, and the reaction at the pin at B right here. So this problem is a little bit trickier just due to the start of it. Once you get going on it and you get the correct free body diagram for it, it is just as easy as the previous problems that we've covered on this channel. So what we are only concerning ourselves with is what's going on here at point B and what is going on here with this rod at point C, because that's where the boom connects in at. And that's what we're asking for, is what is the tension in this rod? So that would be what kind of force is being transferred into the CD rod, and what is the reaction at point B? So let's draw a free body diagram, and I'm going to represent this portion, the boom, as my free body diagram. So as I said, the free body diagram in this one is a little bit harder, but once you get it, everything will make much more sense. So we're going to put this as point A. This will be point B. This will be point E. And this will be point C. So it's like I'm slicing through here, and this is where all my points are, except for point C, we just dropped down a little bit. So we have at A, we have our overall load that's being applied, which is the 25 kilonewtons from the weight. And then we have this 3 kilonewtons of force from the actual self weight of the crane boom. So we're just going to put that right here at 3 kilonewtons. And then I have my B sub y, that's one of my reactions I'm looking for. So I'm just going to assume that that reaction is reacting upward, and I'll just call it B sub y. And then I am told right here, knowing that the tension is 25 kilonewtons in all portions of cable AEF, well, if I am like slicing through right here, this cable AEF is part of that free body diagram. It is interacting through that cut line, the portion I am looking at. So point E will actually have a force being applied with it. And this force will actually be the 25 kilonewtons, also in the downward direction. So this kind of goes with, and let me do C sub y, then I'll explain why E is downward and why C sub y, I am assuming in the downward direction as well for my tension and my reaction here. So this kind of goes along with internal forces. What's going on internally here? And you have to think about it this way. So if I had my pin here at B, and then I have this cable going through like this, and then I have this piston right here at point C. So with the forces cutting through here, B, we can understand that's a pin. So we can possibly have all types of reactions except for a moment reaction. Well, as I said, let's say we are slicing through this portion right here. So what's going to happen is that I'm going to end up with a cable that looks like this, and then a rod that looks like this at point C. Well, we know if we slice through here that this is 25 kilonewtons in tension on that cable. Well, I just sliced through it right there, and well, it is pulling now in that direction 25 kilonewtons. So that is the reason why that one will be downward, because if you slice through it, you're still having to pull with it, as with this picture shown here, in tension. Now, looking at the piston of CD, let me redraw the piston a little bit here, make it a little bit better. So if we have our piston from C to D down here, and I'm having trouble making it to scale here. So let's say we had this, and this will be our point C, and then we slice through here, and this is the remainder of our piston down here, and that's connected into our bottom of our truck here, or our mobile crane portion. So if we're thinking about intention here, well, that means that the rod is going to be moving in that direction, right? It's going to be moving upward relative to the bottom of this vehicle. It's going to be expanding upward in tension, because you can also imagine it like this, like a seesaw about point B here. If you have a force that is pushing down on this end, let's say someone is pushing down on the seesaw on this end, and this is just a pin, well, it's allowing rotation, so this whole thing is going to try to rotate like that. So this end is going to want to lift upward. Well, the piston is not going to allow that to lift upward. It's going to try to resist that, and then it's trying to go downward in its reaction. Because remember, reactions are reacting to forces. So this thing, even though I've drawn it downward, it will still be saying that the piston is in tension. Because if you look at it like a cut section again, well, this piston is expanding upward. Well, this has to be reacting downward in order to cancel with those external forces. So that's why I have C sub y going downward, and that is why downward still makes sense that the piston would be in tension. It's not saying that this force is being all transferred like that down into the piston. It's saying that is the reaction force from the piston trying to go back downward because it's being pulled in tension. So I hope that was a good explanation about why E, the cable, 25 kilonewtons is downward, and why C sub y should be assumed downward. So that is the difficulty of this problem, is just setting up the free body diagram and understanding what all the force directions are, what all your assumed direction should be, and everything of that nature. So let me erase all this right in here, and then we can actually get started calculating our reactions, which are the tension in the rod, which is C sub y, and then the reaction at point B, which is B sub y. Okay, well, this is an equilibrium problem. So once again, we have our possibilities here of summing forces in the x, which have to be equal to 0, summing forces in the y direction have to be equal to 0, and then summing moments about a point having to be equal to 0. Well, technically point B could also have an x directional force to it, but there's no other x directional forces being applied. So I don't have to sum forces in the x direction because, well, there's no applied forces in the x direction, and there's nothing in the x direction or any type of direction that would cause a horizontal reaction at point B. So the only thing that point B will be B sub y, which is the vertical. So I'm left with two equations here. Well, I have B sub y upward, C sub y downward. Those are both in the y direction. So if I go to solve forces or some forces in the y direction, I would get two unknowns and not able to solve it. So let's go straight to our moment. And let's go ahead and let's do part A first, where it says the tension in the rod. So in order to get C sub y, I would have to sum moments at B, so that B would drop out of my equation. So let's do that. So summing forces, or summing moments, sorry, at point B, taking counterclockwise as positive for my equation. Let's just run through our forces here. And please note that the 50 kilonewtons of force from the actual portion that is touching the ground of the vehicle does not matter, because I am only isolating this portion up here. This 50 kilonewtons will come into play if I was looking at something that was actually attached down here, like point E or point F or point D, or if I was looking at the overall reaction of the wheels at H or K. Since I'm only looking at a portion of the member, I can just isolate that portion out. It's because all the forces that are causing reactions up here are actually on that portion itself. So summing moments at point B, I would have my 25 kilonewtons at point A, and it would have a distance to point B of 2 plus 0.6, which is 2.6 meters. It will be rotating counterclockwise about B, so it is positive. And then I would have my 3 kilonewtons of force here from the self-weight. Its total distance to point B is 0.6 meters. It would also be positive since it is rotating counterclockwise about B. B sub y I'm not going to include because it goes right through my point, so its perpendicular distance is 0. And then I have E here, which is 25 kilonewtons of force, times its distance to get it over to point B, which is 0.4 meters as shown up here. This one will be rotating clockwise about point B, so that is negative based upon my sign convention. And then I have C sub y, I have it assumed downward. So it will be rotating clockwise about point B, and then I need a distance, which would be 0.7 meters. And that's everything that I have in my moment for that particular portion of the mobile crane for the boom. And then C sub y is my only unknown in there. So you're just going to have to rearrange and solve for C sub y. And when you do so, you get a positive 81.14 kilonewtons of force. So the positive coming out means that I assumed the arrow direction correctly. So that reaction is going downward. But that is not the final answer. It's asking for what is the answer, what is the tension, which that is the value in tension. Just drop off the minus sign. So you would say 84.14 kilonewtons of tension in rod CD. And that would be the answer for part A. Keeping in mind, it is going downward because that rod is reacting and trying to go back to its normal position because it's being pulled in tension. So it's trying to go back downward. So that's the first part. The second part of the problem asks for what's the reaction at pin B. So now that we have C, which is 81.14 kilonewtons, we can just sum forces in the y direction and get B sub y. So let's do that. So summing forces in the y direction, all have to cancel and be equal to 0 for equilibrium to be true. So we would have our minus 25 kilonewtons of force minus the 3 kilonewtons of force plus B sub y going upward minus off 25 kilonewtons of force minus off 81.14 kilonewtons of force equal to 0. So pretty much B sub y has to resist everything that is being applied here. So B sub y would end up to be 134.14 kilonewtons of force in the upward direction. And that would be my only reaction at the pin because there is no horizontal reaction. B sub x is 0. And remember, a pin does not have any rotation as a reaction at its point. That's only a fixed condition. So we could only have the x and the y. And those are my two answers for this problem. Once again, this problem, the only difficult part of it is actually setting up the free body diagram. Once you set up the free body diagram and get all your arrows in the correct positions and correct orientations with the correct amounts, the problem boils down to a pretty simple reactions problem of summing moments and then summing forces in either the y or x direction. Now, with all questions and with all reaction questions, you can always do a final check to make sure that your problem is correct, that you have the correct answers for it. And that would be summing moments at your other point that you didn't sum moments at in the beginning. Well, we summed moments about point B. So let's sum moments about point C and see if everything still cancels here. So I'm going to scroll down so the distances will not be available to you. But just keep in mind that the 25 kilonewtons all the way to point C would be the total up here, which is 3.3 meters. And then the 3 kilonewtons over to point C would be 1.3. And then B over to point C would be 0.7. And then finally, this other 25 kilonewtons at point E would just be 0.3 over. So writing out that equation, so this would be our check. Let's do our check in blue just so it looks different. So summing moments about point C equal to 0, taking counterclockwise is positive. So the 25 kilonewtons, as I said, would have a distance of 3.3 meters. It was pointed downward, so it would be rotating counterclockwise about point C at the end there, so it's positive. Same reasoning behind the 3 kilonewtons being positive. Its distance would be 1.3 meters over to C. Point B, B sub y is going upward, so it would be rotating clockwise about point C, so that'd be negative 134.14 kilonewtons of force times a distance of 0.7 meters. And then the 25 at point E would also be rotating counterclockwise about point C, so it is positive, times its distance of 0.3 meters. And that would be it, since CY goes right through C. Do not include it in your moment equation. And what does this pop out to be? Well, it doesn't pop out to be exactly 0. It pops out to be 0 or minus 0.18. That's not exactly 0, but that is an extremely small value. As I've been saying in these videos, it may not necessarily always come out to be 0 at the end because of rounding. Well, we had a round of 81.14 and a rounding of 131.14. So what you would do, just to make sure that you're okay, you would take that value over whatever answer you're applying in there, or typically what I do is I take it over my smallest answer. So it'd be 81.14, and that would be 0.0022. That's how much of a ratio you are off the correct answer by. Anything that is 0 point something is okay, and we are 0.0022. So whenever you don't get 0 here, as long as you are close to 0 based upon how large your other values are, it's okay. It's just a rounding difference. Now, if this thing was like 7 or 6 something, that's pretty high. That's a pretty large percentage based upon what your numbers were. So it is 0.18, which is that small of a ratio. So in my book, that is okay. It's just a rounding difference. So I hope this video was helpful. And if you want to see more problem solved this Friday, please check out the other videos on our channel, as we are trying to upload daily and build up our inventory here. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel, because all of that does help us. Thank you for watching, and I hope you have a fantastic day.